Hi, my Math 40 plus students. So today we are actually going to be starting chapter 5. My hope is to get through 5.1 and 5.2 today. I could probably get through a little bit more, but I think I'll just handle like 2 sections per video. So today 5.1, 5.2, and next week we'll cover the rest of chapter 5. If I do feel like we need to speed up, I will make another video over the weekend and I'll post that for you. And of course, as always, I'll email you updates ahead of time. Okay, so chapter 5 actually starts getting into trig identities and verifications. We'll talk about more of this as we go through. I'll go a little quickly in terms of the explanations for now. And then if you guys have questions, you can always ask about them. So first and foremost, want to mention that an identity. Nope, I did. Okay, that's not working. Let's try that again. An identity is an equation that is satisfied by every value in the domain of its variable. So like a quick example of that, you might remember difference of squares for factoring. And essentially that's saying that if I have the two factors a plus b and a minus b, and I FOIL them out, then I get a squared minus b squared. Okay, so this is what's called an identity, because no matter what real value for a you put in and real value for b you put in, it always comes out true. Okay. Let me go ahead and clear this part out now. I know I just wrote it. Okay, so now the fundamental identities. We've already talked about a few of these previously, but it's been a long time. I think it was in chapter 2 that we started introducing these. So remember cotangent of theta, that's going to be cosine theta over sine theta. Secant theta is 1 over cosine theta. And cosecant theta is 1 over sine theta. So these are called reciprocal identities. This particular one is the reciprocal of tangent theta, reciprocal of cosine theta, and the reciprocal of sine theta. Okay. Now the quotient identities are next. Let's do a lighter blue here. So for the quotient identities, tangent theta is sine theta over cosine theta. And then cotangent theta, cosine theta over sine theta. Hold on, let me pause the video for a moment and wait till some of this noise passes by. All right, the joys of not being in the office. Okay, so the Pythagorean identities are next. Oh, one more thing I want to mention about the quotient identities. They're called quotient identities because they're quotients of different functions. So we have the quotient of sine theta over cosine theta and the quotient of cosine theta over sine theta. Now the Pythagorean identities, we actually did talk about these long ago. So sine squared theta plus cosine squared theta is equal to 1. Tangent squared theta plus 1 is equal to secant squared theta. And 1 plus cotangent squared theta is equal to cosecant squared theta. So review these from chapter 2. We actually did an exercise on this where we derived these using X, Y, and R. So if you need some help with that, just let me know. And then even odd identities, essentially, let's do another color here. This group odd functions. This group at the end, odd functions, and the group in the middle is actually of even functions. So remember for that, if you have an odd function, when we take the function f and we plug in negative x, we expect to get negative f of x out. And for an even function, if we take f of negative x, we expect f of x back out. Also covered these ones in detail a while ago, so let me know if you have questions about that. You can check the chapter 4 videos about graphing sine and cosine functions to get more detail about this. So we would expect negative sine theta and negative cosecant theta, odd functions. Let's go to the odds at the end, negative tangent theta and negative cotangent theta respectively. And then the even functions, that's where you just get cosine theta and secant theta back. All right, let me save that picture, and then you can go ahead and pause the video if you need to look at this some more. I'm gonna clear this out. Now, what I want to talk about next is algebraic manipulation. So that just means taking an expression or an equation and making it look different. So for example, here tells you that two other forms for our Pythagorean identity, the first one, are given below. So let's just look at how we get from here to here. So start with sine squared theta plus cosine squared theta equals 1. We subtract cosine theta from both sides, sorry, cosine squared theta. Then we wind up getting sine squared theta equals 1 minus cosine squared theta. So algebraic manipulation, because we're using algebra to move terms and make our equation look different. Okay. All right, so let me go ahead and save that picture, and I'm going to clear this out and go ahead and move to the second page. Let's hope this actually does this right, because it hasn't been. Nope. All right, let me pause video for a second. So I'm actually getting into the problems now. I'm not going to go over every single one, but we will go over a good portion of them. So the first question we have here, we'll just go over part A for this. You have cosine theta as 5/8, and theta is in quadrant 4. You want to find this function value sine theta. So for this, you want to use your Pythagorean identity because it relates sine theta and cosine theta. Okay. Now we could plug in and back solve, but if you know that you're looking for sine, it might help you, especially for the future sections we're going to do for chapter 5, to be able to manipulate to get sine theta alone. So first thing we're going to do is subtract cosine squared theta from both sides. We have sine squared theta equals 1 minus cosine squared theta. And then in the next step, we're going to take the square root of both sides. And when we do that, we have to remember that there's going to be a plus minus in front. Okay. Now, this is when Q4 comes in. Let's use purple. So for Q4, remember that sine theta is negative here. So we're going to choose negative here. Okay, and now everywhere we see cosine theta, we replace it with 5/8. So sine theta is equal to negative square root 1 minus the quantity 5/8 squared. And you could use a calculator for this part if you need to. 1 minus 5/8 squared. That's going to be 39/64. Under the radical, still with a negative in front, we can separate the radical. And then we simplify the bottom. Okay, if this weren't a simplifiable radical on the bottom, you'd need to rationalize. So remember to review your notes for that. And take a picture if you need it. I'm going to go ahead and clear out the screen. If you are joining me at this time, if you have any questions throughout this portion, just go ahead and leave them in the chat box, and I'll check that when I take a break in a few problems. Okay. So for this particular box, when taking the square root, be sure to choose the sign based on the quadrant of theta and the function being evaluated. All right, let's go to classroom example 2. This is writing one trig function in terms of another. So the problem here is we don't have one function at this point that relates just tangent theta and cosine theta without another trig function. So remember that tangent theta is sine theta over cosine theta. Okay. Now we want all cosine terms, right? So we need to get rid of sine theta. And in order to do that, we must rewrite sine theta in terms of cosine theta. So you have to go back and look at your equations and think, okay, well, which equation relates sine theta and cosine theta without any other trig functions involved? And that would be your Pythagorean identity. Okay, and we already did this isolation in the last problem. So now, wherever we saw sine theta, we're going to replace it with all the stuff on the right here, including the plus minus. So now we have tangent theta in cosine terms only. So this one is actually an important one to know how to do because I believe I asked that to you on a quiz. Something similar. Okay. Let me go ahead and clear that out. and move to the next page. Write 1 plus tangent squared theta over 1 minus secant squared theta in terms of sine theta and cosine theta. Oh no, hold on a second. Still messing around with technology here. Okay. Stop highlighting, please. Okay, there we go, draw. Okay, so we have an expression. We want to write it in terms of sine theta and cosine theta only, and then simplify the expression so that no quotients appear. That essentially means no fractions. Okay, so for this, let's go ahead and start with our original expression. We're first going to change this to tangent theta, the quantity squared, and secant theta, the quantity squared. You wouldn't really have to draw it out this way if you're already comfortable knowing what you need to replace. It's just so that you have an idea that we're gonna have tangent theta replaced here with another expression that relates sine and cosine. And same thing with secant theta, we'll express with sine and cosine terms appropriately. So 1 plus doesn't change. 1 minus doesn't change. The equations that we're going to replace here, sorry, the expressions we replace, tangent theta is equal to sine theta over cosine theta. And secant theta is equal to 1 over cosine theta. So this is what's called a complex fraction, because you have fractions in your numerator and denominator that can be simplified. So we have 1 plus sine squared theta over cosine squared theta divided by 1 minus 1 over cosine squared theta. Now from here, what you can do, you can with your hand just cover up this denominator here and think about how I would combine the 1 and the sine squared theta over cosine squared theta. So essentially, you're going to need to find the LCD. Let's do the top in orange. LCD for the numerator of the complex fraction is cosine squared theta. And then for the denominator of the complex fraction in green, the LCD is actually going to be the same in this case. It's not always the case though. So remember here, you're going to take 1, and then that's going to become cosine squared theta over cosine squared theta. You're still adding sine squared theta over cosine squared theta. And then dividing all that by, change the 1 into cosine squared theta over cosine squared theta. Subtract 1 minus cosine squared theta. Okay, I'm going to erase the LCD part here now. Actually, instead what I'll do, I'll just select it and move it over here. Okay, so now we continue. A little longer of a problem here for sure. All right, so we can combine, like once our fractions have the same denominator, take the numerator, sum it, put it over the same denominator, which is common now. divide, you have cosine squared theta minus 1 over cosine squared theta. Now, essentially what's going to happen next, you have one fraction divided by one fraction. So you could rewrite this cosine squared theta plus sine squared theta over cosine squared theta divided by cosine squared theta minus 1 divided by cosine squared theta. So old school division, so that you see you're going to be multiplying by the reciprocal of the second fraction. So cosine theta actually cancels out. So cosine squared theta cancels out. And you're left with cosine squared theta plus sine squared theta divided by cosine squared theta minus 1. Now, when you're comfortable enough with this step, you can actually skip that. The reason is we already showed the long way how this works. Notice, if we're back up to this step, if I see a cosine squared theta in the denominator here and a cosine squared theta in the denominator here, they'll both cancel out. Okay, let me undo that. It's not what I wanted to do. Give me my draw function. Okay, so cosine squared theta cancels with cosine squared theta for this reason. So then this step turns into this step. Okay, now here's where we need to continue to use algebraic manipulation. Note that this is a Pythagorean identity. And cosine squared theta plus sine squared theta, what is that equal to? That's equal to 1. Now, let me put this over here. For cosine squared theta minus 1, what is that equal to? Start with sine squared theta plus cosine squared theta equals 1, since that's the identity that relates cosine squared theta and 1. Okay, so it relates it to a sine squared theta. So actually solve for cosine squared theta minus 1 on one side. So I'm going to subtract sine squared theta from both sides first, and then subtract 1 from both sides. So what we found is that cosine squared theta minus 1 is equal to negative sine squared theta. Okay, and then the last step, you don't want any quotients to appear. So you don't want any fractions. So you think, okay, well, is there a reciprocal function that could help me here? Okay, well, the negative is going to stay out in front. What is 1 over sine squared theta? That's cosecant squared theta. Okay. Go ahead and save that if you need. Same thing, if you have any questions, go ahead and write them in the chat box and I'll get to them. I want to go ahead and get into 5.2. And then once I'm done with 5.2, I'm going to take a break so that I can check in. All right, let me clear this out. And then let me zoom out here and see if this works correctly. Nope. Here we are. Oh, okay. Should have just froze this for a minute. Okay, so now we're gonna fill in the 5.2 stuff. So 5.2, we actually start verifying trig identities. Essentially, you're trying to get one side of your equation to look like the other side of the equation, but not by using traditional solve for like method. You're actually just simplifying each side algebraically. So we'll talk about that and see if you can pick up on that. So here's some hints. Learn the fundamental identities. This one is really, really important for you. You will need to know these for the rest of your math career. It also pops up in other sciences as well. Also be aware of equivalent forms of the fundamental identities. So like, for example, this is an equivalent form of an identity we already know, right? If we added cosine squared theta to both sides, we would get sine squared theta plus cosine squared theta equals 1, which is our Pythagorean identity. One of them, one of the three. Okay. Also, we're going to rewrite the more complicated side of the equation. Typically, it's a little bit easier than having to manipulate the simpler looking side into the complex one. You'll see about that shortly. It is sometimes helpful to express all trig functions in the equation in terms of sine and cosine and then simplify the result. So basically the last example we did, sometimes it's going to be easier to use that method. Change everything into sine and cosine terms and then simplify down until you get another common trig identity or function. Let me go ahead and save that picture and clear this out so I can move down. Usually any factoring or indicated algebraic operation should be performed. So here's some common factoring things here for you. For one, these are, there we go. These are what are called perfect square trinomials. And that's because you have perfect squares on the side. And when you FOIL them out, they turn into trinomials. Okay, so when you factor these trinomials down, you wind up getting these factors. Okay, one more thing to mention about this. Basically, if you were going from your side here on the left to the right, that's actually factoring. If you're going from the right side over here to the left, that's called distribution. Okay. Now over here, you have sums and differences of certain items. These are called sum and difference of cube respectively. You have cubes on this side that are summed or differenced, and then these are the factors that they break down into. So going from here over here is factoring. And going from this side to this one is distribution. And then this last one here is called a difference of square. You have squares over here, perfect squares. And then when you factor them down, you get these two factors out. Okay. All right. Now, here's an example that it gives you. If you have the expression sine squared x plus 2 sine x plus 1, that can be factored down to sine x plus 1, the quantity squared. So for this, it helps. Let some other letter like w be equal to sine x. And then everywhere we see sine x, we're going to replace it with w. So here we get w squared plus 2w plus 1. If you need help with factoring trinomials, definitely let me know. I can bring some extra factoring practice with you. But you can use AC method on this if you get super stuck. You're matching to AW squared plus BW plus C. So A is equal to 1, B is equal to 2, C is equal to 1. We have AC on top, B down below. We want numbers that multiply to A times C, which in this case is 1. And we want numbers that add to 2. Which is B. So those numbers would be 1 and 1. So we have the factors W plus 1, W plus 1. One other note. If A is not equal to 1, must use grouping. We'll see that when we need it. Okay, so now go ahead and replace wherever you saw, oh, and one more thing. This is actually W plus 1 squared. And remember, W is equal to sine x. Okay. Let me go ahead and clear all that out. Actually, before I do, I'll just keep going here. So the sum or difference of two trig expressions can be found the same way as any other rational expression. So actually, I'm going to clear this out. Sorry. Okay. So like if you have 1 over sine theta plus 1 over cosine theta, and you're trying to simplify that, kind of think, what would I do in the case of 1 over A plus 1 over B? Well, I would get the LCD, which in this case would be AB. Then I have AB for both my denominators. What factor is missing from the first denominator? The B. So I multiply 1 by B on top. Second fraction is missing A as the factor, so I have 1 times A. And then I have a common denominator with B plus A on the top. Okay, now in this case, A could be thought of as, A could be thought of as sine theta, and B can be thought of as cosine theta. So let's go plug that back in. That'd be cosine theta plus sine theta over sine theta cosine theta. So let's fill this in. Okay, well, my LCD in this case would be sine theta cosine theta, A times B. The factor that's missing from the first fraction, cosine theta. And sine theta is missing from the second. We have a common denominator now. And we have the added terms on top. So check this out. Okay, and the last bit here, when selecting substitutions, oh, actually, sorry, there's one more bullet point after this. Okay, so when selecting substitutions, keep in mind the side that is not changing because it represents the goal. So let me just fill this one in first, and I'll show you two ways to verify this as our intro. So for example, to verify that the equation tangent squared x plus 1 equals 1 over cosine squared x is an identity, think of an identity that relates tangent x to cosine x. In this case, because secant x is equal to 1 over cosine x, and secant squared x is equal to tangent squared x plus 1, the secant function is the function that's the best link between the two sides. Okay. So let's do this. Verify. We're going to verify this equation here. So the first thing, you want to actually draw a little line between your sides so you remember you cannot algebraically cross that line. So this is what we're trying to show, right? So what we're doing, we're trying to manipulate one side to look like the other, okay? So you cannot like say, okay, I want to subtract 1 on both sides. Now I have tangent squared x equals 1 over cosine squared x minus 1. That's a no-no. You're not trying to solve for x. You're trying to verify that left side equals right side. So let me clear this part. So instead, let's start on the left side. Let's do left-hand side to verify it's equal to the right-hand side. So for this, we would say, well, tangent squared x plus 1, is there an identity for that? Well, yeah, there is. That's secant squared x. Oh, and then secant squared x, is there an identity for that? Well, yeah. Let me take this back one more step just in case you don't understand that one. So remember, secant squared x, that's secant x, the quantity squared, and secant x is equal to 1 over cosine x. Exponent rules, square goes to top and bottom. 1 squared is just 1, and the bottom turns into cosine squared x. So we've matched the sides. Done when sides match. Okay, so that's one way. Now let me erase this. We're going to verify the other direction. We're going to show the right-hand side translates to the left-hand side. So cosine over, 1 over cosine squared x, that is 1 over cosine x, the quantity squared, which is secant x, the quantity squared, which is secant squared x, which has the identity tangent squared x plus 1. Sides match, we're done. All right, let me clear this out. One more bullet point to talk about before we get further into some problems. If an expression contains 1 plus sine x, multiplying both numerator and denominator by 1 minus sine x would give 1 minus sine squared x, which could be replaced with cosine squared x. Similar procedures apply for 1 minus sine x, 1 plus cosine x, and so on and so forth. Okay, so let's introduce what's called the conjugate of a factor. So if I start with a factor a plus b, its conjugate is a minus b. And essentially the goal of finding that is when you take those factors and multiply them together, you eliminate the middle terms and just get a squared minus b squared. Okay, so if we start with 1 plus sine x, and then we multiply by the conjugate, that would be 1 minus sine x. So for this, you would need to FOIL. You get 1 times 1, which is 1. 1 times negative sine x minus sine x. Sine x times 1, that's plus sine x. And then you have sine x times negative sine x, that's negative sine squared x. So the middle terms cancel, and we're left with 1 minus sine squared x. Now from Pythagorean identities, we know that cosine squared x plus sine squared x is equal to 1. So if we manipulate that, we have cosine squared x equals 1 minus sine squared x. Okay, you save that and clear. All right, let me start with classroom example 1, and then I'm going to move to classroom example 3. Classroom example 1 asks you to verify the following. You have options here. You can either work with one side or work both sides and try to get them to be matching. Basically, you just need to have, let me make a line here. You need whatever expression you get on this side to equal the expression on this side. So left side must equal right side. So for this, which side looks more complicated? Like what side looks like you can do more algebraic manipulation on it? Well, the left-hand side. For this one, you would need to change tangent theta into sine and cosine terms first and blah, 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 blah. So let's look at this way. We have, essentially we're going to show here is left-hand side turns into right-hand side. So first thing we're going to do is distribute. We have secant theta sine theta plus secant theta cosine theta. And then we're going to turn secant into its reciprocal. So secant theta is equal to 1 over cosine theta. So we have 1 over cosine theta times sine theta plus 1 over cosine theta times cosine theta. Okay, now definitely practice with your algebra here. There's an activity for the second half of this meeting today that will cover that. So essentially, this is 1 over cosine theta times sine theta over 1. Okay, multiply straight across. You're going to get sine theta over cosine theta. Same thing for the second fraction here. You have 1 over cosine theta. That's multiplied by cosine theta over 1. Multiply straight across, you get cosine theta over cosine theta, which is just 1. And then we know that sine theta over cosine theta is equal to tangent theta. So we're going to replace this with tangent theta and keep the plus 1. And that is equivalent to the right-hand side here. See how they're exactly the same? That's what you're looking for. Okay. For this one, let's actually try to confirm the other way and see what the differences are. So for this one, we're going to show right-hand side turns into left-hand side. So for this one, you would change tangent theta into sine theta over cosine theta. That's plus 1. And then you would need to recognize that you essentially want to have a sine theta and a cosine theta eventually in here that are going to be added together inside of a factor. So it's not intuitive. What you're going to do is change the 1 here into cosine theta over cosine theta. The reason we did that, now on the top here, when we combine our fractions, we're going to have sine theta plus cosine theta. And then we can actually distribute out a 1 over cosine theta. Okay. If it helps, let's take it back one step. Let's actually combine the fractions first. Okay, so combining the fractions. And then in the next step, factor out 1 over cosine theta. So then in the front, that 1 over cosine theta turns into secant theta. And you still have the multiplication of the factors, sine theta plus cosine theta. Okay, right-hand side exactly matches left-hand side. So definitely think to yourself, which way worked easiest for you to understand? That's the way that you're going to want to try to stick with for these types of problems. Let me clear this out. And I'm going to move to number 3 next. I think I will do number 3 and number 4 for now. And then I'll warm up next time with number 5 before we get into 5.3. Okay, so let me escape here. Let me actually pause the recording first for a minute. All right, so we're at classroom example 3. The way that I'm going to do it, I'm going to show that the right-hand side turns into the left-hand side. Again, you have options. The reason I'm doing it that way, again, I don't want to change tangent t and secant t into reciprocal functions and quotients and all this, that, and the other. Instead, go this easier route of distributing first. So we're going to FOIL on this side. We have, so first, outer, inner, last. So 1 times 1 is 1. We have minus cosine t next, plus cosine t, and finally minus cosine squared t. So middle terms cancel out. And we have 1 minus cosine squared t. Now this, hopefully you're starting to get familiar with the Pythagorean identities and their forms. Sine squared t plus cosine squared t equals 1. So sine squared t equals 1 minus cosine squared t. So where you see the 1 minus cosine squared t, you're going to replace it with sine squared t. Okay. And then this part takes a little bit of finessing. If you feel uncomfortable trying to work any further on this side, just go over to the other side and start trying to manipulate, turn tangent t into sine cosine terms, turn secant t into cosine terms, and see if you can get a match. But essentially what you want to do here, you can say, okay, well, I could put this over 1. Okay, that's allowed because, you know, this simplifies to sine squared t, right? Now, how would I get a tangent squared t from the numerator? Well, if I divide by cosine squared t, okay, that will give me the tangent squared t I want. Well, whatever I divide on the top, I would need to also divide on the bottom. Okay, so I don't change my expression. And then I see, oh, sine squared t over cosine squared t, that's going to be tangent squared t. And then on the bottom, 1 divided by cosine squared t is secant squared t. Okay, let me save that. Let me clear this out. And then the last one I'm going to do is number 4. So for this particular one, I'm going to show that the right-hand side simplifies the left-hand side. Okay, so this is where we're going to want to use conjugates. Let's move this up, no. Okay, there we go. All right, so we're going to start by multiplying the right-hand side, top, bottom, by the conjugate of the denominator. Okay, so the conjugate of secant x minus tangent x is actually going to be secant x plus tangent x. Okay, so note that what we're going to be doing here is multiplying by secant x plus tangent x as a factor, top and bottom. Kind of think you're multiplying by 1, essentially, so you're not changing your expression value. So we have cosecant x times secant x plus tangent x, all divided by, now for this bit, secant x minus tangent x multiplied by its conjugate. We can do that off to the side. So first term is secant squared x. The middle terms will cancel, but we'll write them anyway. We have plus secant x tangent x. Give myself some room here. Okay, let me undo that. Okay, there we go. Okay, so first term secant squared x, next term secant x times tangent x, next term minus tangent x secant x, and then lastly minus tangent squared x. So these terms cancel. We have secant squared x minus tangent squared x. Okay, so I'm going to put that here. And I'm going to erase this stuff. Okay. All right, now for the next bit, we're thinking, okay, so can I replace, okay, undo that. Can I replace this with any identities? Yeah, I can. Start with identities that relate secant and tangent. So remember, tangent squared x plus 1 equals secant. So 1 is equal to secant squared x minus tangent squared x. Okay. So now I'm going to replace that part by 1. Okay, now start to notice, okay, the 1, we don't have to write it anymore. You should start having familiar forms as you go through this. Kind of look at this part. We have the secant x plus tangent x right here. So then we're trying to look and see, well, how can I get a sine x out of this in the denominator? Reciprocal function. So this is going to be here, 1 over sine x, and then you still have this part off to the side. And you can actually stop there because you should be able to realize that this entire factor in the next step will be divided by sine x. So we've showed that the right-hand side simplifies into the left-hand side. You could have also started from the left-hand side and shown that it was equivalent to the right-hand side. So next time I'll cover working with both sides, and then we will get into 5.3. So let me go ahead and pause recording.